Okay, Tyler, I decided for you to start with Chapter 11 because you have, I think, attempted all those problems and have something in. And I've chosen to do, I think I'm going to work out 3 different problems, but they'll be in 3 separate videos. So the first one is problem number 23. And this is in response to the increasing weight of airline passengers. The Federal Aviation Administration in 2003 told airlines to assume that passengers average 187 pounds. We're going to be using this 187 pounds is going to be mu in this situation, including clothing, carry-on baggage. But passengers vary, and the FFA or the FAA did not specify a standard deviation. However, a reasonable standard deviation is 37 pounds. Weights are not normally distributed, especially when the population includes both men and women because they vary from each other. But they are not very non-normal. So we might be able to use a sampling distribution of the averages. A commuter plane carries 17 passengers. What is the approximate probability that the total weight of the passengers exceeds 3,579 pounds? Okay, so we're going to go ahead and get started with this. And the first thing I've done is to have written down some of the given information here that we're going to use. And we know that the mean is 187 from the problem. The standard deviation, since these are averages, not individual scores, it's a sampling distribution, the standard deviation is going to be sigma divided by the square root of n. So square root of 17 in this case, n is 17. We would use this for standard deviation anytime the numbers that we're using are averages rather than individual data. The question asks us to find the probability that the total weight is greater than 3,579 pounds. Since we're dealing with averages, that means that x bar is going to equal the total weight divided by 17 in this problem. And we're going to be converting this to a z-score and looking it up in the table. And since table A gives us the area that's to the left of the z-score, or the probability that it's less than or equal to a given number, we're actually going to be taking 1 minus the probability that x bar, or the average weight, is less than or equal to 3,579 divided by 17. So to figure out the probability that x bar is less than or equal to 3,579 divided by 17. It's kind of an ugly decimal, so I'm just going to leave it in fraction form and let my calculator do all my work for me. So putting this in the formula for z-score, where we have x bar minus mu divided by sigma divided by the square root of n, I do that calculation and I get 2.62. You do have to be a little bit careful in putting this calculation in your calculator. You need the whole numerator in parentheses and the whole denominator in parentheses. You should get a z-score of 2.62. We're then going to go look that up in table A. And when we look that up in table A, we get 0.9956. So that is the probability that the average weight of those 17 people is less than or equal to 3,579 divided by 17. Since we want to know what is the probability that it's greater than that, we need to take 1 minus the probability that it's less than that. And we end up with 1 minus 0.9956, which is 0.0044. Just a couple notes on here. The calculator keystrokes that you would use to get that to put in there, you might want to make note of. Notice the whole numerator's in parentheses, the whole denominator's in parentheses, and I had to make sure you close the denominator parentheses. One separate set is just for the square root when you put it in there. So in our figure here is our normal curve. Here is the mean, which the z-score would be 0, and the mean was given as 187. And 3,579 divided by 17 is 210.5294. So it's actually going to be on this side, 210.529. So the question wants us to find this area. So we convert this to a z-score. Oops, sorry about that. We're going to convert that to a z-score. When we convert that to a z-score and look it up in the table, it gives us the area that is to the left. So if I want the area that's to the right, I need to take 1 minus the value that I look up, the z-score for 2.8, or the z-score of 2.62. And that's why we're having to subtract it. I hope that helps you. Let me know if you need more information on that one.